Alright, good evening class.
Good evening.
Thank you guys. It shouldn't come as a surprise, but today we're going to be going over reflecting points to reflect figures. We've been talking about triangles a lot, and today we're going to start on our transformations and reflecting section. So, I would start with a little check-in, but we're a little pressed on time today. I'm sure you guys are all feeling great, so we're going to move past that. But let's start by getting you guys together with a partner. If you guys want to come on up and grab one card, based on that card, we'll do the partners with 2 aces, 2 kings, and 2 queens. So mine goes an ace, and partner up with them. If you pick an ace.
Who's got a king?
And go ahead and sit with each other if you like.
Yeah.
Alright. Everyone's got their partner. So let's go over the standard for today. Can I get a volunteer to read this for the class? Cole?
Given a rectangle, parallelogram, trapezoid, or regular polygon, students can describe the rotations and reflections that carry it onto itself.
Beautiful. And like I said, we've been going over triangles a lot, so we're going to stick with triangles today when we're going over this. And then for today's objective, can I get one more volunteer to read this? Jared?
Students will be able to recognize and describe the relationship between a triangle and its reflection over a line.
Beautiful. Alright. So we're going to be doing a little warm up to get you guys thinking about triangles. Take a look at these ones. Notice the values for the lines and the values for the angles. Are they similar? Are they different? And here's a quick question. Are these two shapes congruent? Why or why not? Take a second to think about it. You come up with an answer. Raise your hand. Anybody want to share? Cole, what do you think?
I'm gonna say no because the sides are not all the same.
Right, the sides are all the same, and the angles as well. The angles are different. There you go. Now, do you think that we can make these two shapes congruent? If you think we can, what would we have to do? Is there a way to do it? Okay, what do you think?
You might be able to manipulate the triangle itself by like changing one of the sides.
Yes, you can. And that kind of leads us into what we're going to be doing. We're going to be modeling with triangles on GeoGebra. We're not necessarily going to be playing with the angles and the sides, but it's a tool that we could use on that website. We'll be going over that later in the lesson. And then one more. Do you think these two triangles are congruent? Why do you guys think yes?
They look similar.
They look similar? Can we say definitively that these two triangles are congruent?
No.
We can't. Do you know why?
There's no angle or
Right. We don't know the side lengths, we don't know the angle measurements, so we couldn't say that these two triangles are congruent. Alright, so this is our activity for today. If you guys want to go ahead and pull out your laptops right now, feel free. And I will begin modeling our activity. Okay, so when you first open up the link, it's going to take you to this GeoGebra activity where we're going to be playing with triangles and moving them across their line of reflection. So the first part of this activity is going to be moving these dots around. You can move them anywhere on this screen, and what you're trying to do is reflect it across this line. So I think right about here, it looks like that purple dot would be reflected. Then you do the same thing with this orange dot. Move it wherever you think it would be reflected. And again, we're just kind of experimenting with GeoGebra. We're not looking for a right answer immediately. We're just kind of playing around with it. And then let's try this purple dot. And then once you feel like you got the dots reflected over that line of reflection, go ahead and hit draw a triangle and see what it says. So it looks like I messed up. And it gave me a coordinate grid, and I could use this grid to count how many like spots from the line of reflection I need it to be because it's equidistant between the two. If you guys are looking for the link, I'm pulling it up on the next slide. So let's move it around. You see that there are 3 spots in between here and 3 here, so that's going to be equidistant. And there are going to be 2 spots in between the orange and purple, so let's move that one. And then you got it. Once you move it around enough, you keep trying it again and doing different shapes. And then as you move along, I want you guys to try and answer these reflection questions down at the bottom. And if we have time, we'll do a little class discussion about that at the end. So let's go ahead and pull up the link for you guys. And you guys can begin working on the activity with your partner. Feel free to talk as much as you like, work together, and work through those problems. If you have any issues getting the website up, let me know. I'll come help you out.